95.399 times 10 to the power minus 3. Thickness held the same, 1.5. So 4 power 3 times 695.399 power minus 3. Power minus 3 divided by 2.0887 divided by 1.5. And your answer is 887.823 psi. So they are both very similar. Okay. So this is by taking. So you can see down here, right? Remember, you can cross over the centroid, geometric centroid, but you have to know at the top is positive, at the bottom is negative. Or making your life easy, okay, you can just focus on the aluminum. Okay. So that is for sandwich material. We are not done yet. So they still want us to find the maximum the maximum I'm kind of tongue twisted these few days. The at the centroid, okay? So we can now maximum. So now the maximum will occur at the centroid. This is because, okay, the T of steel is also equal to the T of what? Aluminum, which is equal to what? 1.5. Okay, which is equal to 1.5. Right? So now we are going to consider, right? So now we are going to consider this cross section. Okay, so we can just focus on the what? On the steel. Okay, we can just focus on the steel. So the Q of steel, or ST, so the width is, or the N is 1, okay, multiplied by 1.5. The depth is 1.2318. Multiplied by 1.2318 divided by 2. Okay. So this is equal to 1 times 1.5 times 1.2318 times 1.2318 divided by 2 is equal to 1137.998 times 10 to the power minus 3 inches cube. I think we got the same as 1137, yeah, 998, yep. Okay. So therefore, tau at the max, okay, this is equal to the V is equal to 4 times 10 to the power 3. The 2.0887, the I, the Q, and then the Y bar is equal to 1.5, right? Okay, so 4 power 3, that's a 1137.998 power minus 3 divided by 2.0887 divided by 1.5 is 1.453. 1.453 times 10 to the power 3 psi. Okay. Now I'm not tried this before, but I'm going to do it. Okay, well, I'm not tried. So what if can we consider the bottom part? right? So the bottom part has the combination of steel and aluminum. Okay, as I said, I'm not done this before. You should get it. So consider the bottom section relative to the centroid. As I said, I've not done it before. So we can do this. So the Q is equal to the Q of aluminum plus the Q of steel. So we know that this is the N is what? Can't remember the N now. 35 over what? 53 over 145. So 53 over 145 multiplied by 1.5, then multiplied by the depth. The depth is 1 inch, right? The depth is 1 inch, right? The depth is 1 inch. And then we have, so we know one extreme. So 1.76, 1.7682 minus by 1 over 2, right? And then we plus by 1 times by 1.5. Okay, 1 times by 1.5. Now the depth is equal to what? Wait, 3. So 1.782. Wait, let me. So 3. So this is 1.782. 1 divided by 2. So now this is 2 minus by 1.2318. So 2 minus by 1.2318 multiply by 2 minus by 1.2318 and then divided by 2. So this over here is our width, our y bar. Oh, no. What am I doing now? Over here, this is our y bar. This is our depth. This is our width. And this is our end. So this is for the steel. Okay. And this part is for the aluminum. Okay, as I said, I've not done this before. I think the answer should be the same. So 1.7682 minus by 0.5 times by 1 times by 1.5 times by 3 over 145. Okay, is equal to 695.323. Let me do it again. 1.7682 minus 0.5 times by 1 times by 1.5 times by 3 over 145. 695.323. Yep. Okay. And then plus 2 minus by 1.2318. I can square and then divide by 2 times by 1.5 times 1. So I get 442.598 times 10 to the power minus 3. Let me do it again. 2 minus 1.2318 squared divided by 2 times by 1.5 times 1. 442.59. So this will be equal to 695.323 plus by 442.598 is equal to 1137. 1137. Wait, 695.323 power minus 3 plus by over 2.598 power minus 2. So it'll be equal to 1137.921 times 10 to the power minus 3 inches cubed. Okay. So you realize that you can, the values, whether you consider the top or from the bottom of the sandwich material, the answer will be the same. As I said, I've not done this before, and this is the first time I'm doing it. Okay, so the answer will be the same. Either you take from the top or you take from the bottom, like what we have done before since week 8. Okay, you look from the top or you look from bottom, the answer will be the same. And also for what? Sandwich material. So to summarize for sandwich material, be very careful. Okay, the most important thing is so for composite material. Okay, for composite material, you have to remember that the shear stress is equal to V y over IZZ, okay, QZ over T. And the QZ is equal to N with, okay, D y bar. Okay. So that's where our QZ come into this stage. Okay. And the thickness over here, remember, the thickness is always a what? Constant. Okay. The thickness in this formula over here is always a what? Constant. Okay. Are we clear? Well, when we find our when we find our second moment of area, the width, not the thickness now, the width we multiply by the what? By the coefficient, the width. We clear? Okay. Right. So the last part of shearing stress, okay, is going to be for thin wall shearing stress analysis. Okay. Now this is again in shearing stress due to shear force. The formula is really straightforward. I repeat again. The formula is really, really easy. Okay. So what formula are we going to use now? Okay. So the formula is Q. Still the same formula. Small q is equal to VQ over I. Okay. So the formula does not change at all, where Q is equal to width, depth, y bar. Okay, formula did not change. In thin wall analysis, okay. And also the shearing stress is also equal to VQ over IT. Nothing changed. Okay. And then we also apply the rule. That the first rule for thin wall analysis is the V and I. Okay, the rule number 1 is V and I are what? A constant. Okay. And then the second one is still the same. The datum is at the geometric centroid. Rule number 3, still the same. Analysis, okay, starts from distance furthest away from the centroid. Why we say that? Because we have, remember, C minus Y, C plus Y multiplied by what? Where C is the distance furthest away from the centroid. Now, rule number 4, okay, is where Q, the first moment of area, cannot past the centroid. But we also discover that when Q is above centroid, it is